We now know how to solve quadratic equations by factoring. We can also solve equations of degree 2 or greater by factoring if the corresponding polynomial factors. In other words, the zero factor theorem can be used with 3 or more factors. You'll see what we mean when I try and solve this equation. Now, in fact, this is not a quadratic equation. You can multiply it out if you'd like, but if you just notice this first times this first, 2x times 2x squared, that's 4x cubed. So the degree of this equation is 3. So I'd like to solve this equation by factoring. We do still need 0 on one side, which we have, and we need this side to be completely factored. So let's concentrate on this trinomial, 2x squared minus 5x minus 3. Let's see if we can factor further. So I'll rewrite my 2x plus 3. And then I'll draw 2 sets of parentheses. And let's see if this trinomial can be factored. I'll use 2x and x. 2x and x. And I want negative 5 as a coefficient of the center or coefficient of x. What if I put negative 3 and positive 1? Let's check. First times first, that's 2x squared. Outer product, that's negative 6x. Inner product plus 1x. And negative 6x plus 1x is negative 5x. And then don't forget last times last. 1 times negative 3 is negative 3. So I have factored this trinomial correctly. Now notice 0 on one side, and I do have a factored form on the left side. I just simply have 1, 2, 3 factors this time containing a variable. That's okay. We can still use the zero factor theorem with 3 or more factors. We simply set every single factor containing a variable equal to 0. So I'll set this factor, 2x plus 3, equal to 0, or this factor, 2x plus 1 equal to 0, or last factor, x minus 3 equal to 0. And we solve each of these equations. So how many answers or solutions might I get this time? 1, 2, 3, as long as they're distinct solutions. All right, let's check or let's solve this equation. First, I'll subtract 3 from both sides, so I'll have 2x is equal to negative 3. Then I finish solving by dividing both sides by the coefficient of x, which is 2, and I'll have x is negative 3 over 2. That is a solution of our original equation. Or let's solve this. Let's subtract 1 from both sides. So I'll have 2x is equal to negative 1. How do we finish solving this equation? We divide both sides by the coefficient of x, which happens to be 2 again. So negative 1 over 2, and we'll have on the left side x is equal to negative 1/2. That is a second solution. And then for the third equation, we simply need to add 3 to both sides, and we'll have x is equal to 3. This original equation has 1, 2, 3 solutions, and it's just simply an equation of degree 3, and notice it does have 3 solutions. So that's how you can use a zero factor theorem for equations whose degree is 3 or greater. Just make sure you still have 0 on one side and you have a factored polynomial on the other side. Notice that this is an equation in 2 variables, x and y. Suppose we were trying to graph this equation in two variables on a rectangular coordinate system with an x-axis and a y-axis. It's not a linear equation, it is a quadratic equation, but let's suppose we want to find x-intercepts. No matter what you're trying to graph on a rectangular coordinate system, if you're trying to find x-intercepts, you do so by letting y be 0. So if I want to find the x-intercepts of the graph of this quadratic equation in two variables, we would do so by letting y be 0. And if I let y be 0 and then solve for x, look what kind of equation I happen to have. So in finding the x-intercepts by letting y be 0, this leads to a quadratic equation. How do we solve this quadratic equation? We want 0 on one side, like we have, and then we want this to be a factored polynomial. So let's try and factor the polynomial. 2x and x, and I'll try plus 6 because I know that will give me a 12, and minus 1. Let's check. 2x times x is 2x squared. The outer product is 12x. Inner product, negative 1x. 12x minus 1x is 11x. And then last times last is minus 6. How do I finish solving for x? I set each factor containing a variable, and they both do, equal to 0, or x plus 6 is equal to 0. Here I'll add 1 to both sides, and then I'll divide both sides by the coefficient of x, which is 2, and I'll have 1/2. Or here I'll subtract 6 from both sides, and I'll have x is negative 6. So what have I done? I'm looking for x-intercepts of this graph. I let y be 0, I solved, and I got these values for x. That means there are how many x-intercepts if we graph this equation? There are 2. We got 1/2 when y was 0, and we got negative 6 when y was 0. We will not be graphing right now, but I'll let you look at the graph. But notice it will have 2 x-intercepts, and there are the ordered pair coordinates of the intercepts.